now. Okay, so we are going to start back up. We had a week off. I didn't see much activity, but I did hope that we use this week off where we did not go over new content and that we had students who were going over the homework. And especially when we started doing the essence of statistics homework, that helped people to see exactly the skill sets that are needed so that we're able to complete the homework assignments. I'm really excited about how the essence of statistics is working moving forward. Now, this is what I'm going to need though, however. We have a certain number of people who've already participated in this. Now, what I've done is this. In the past, I have set it up so that those who are, stop sharing. So this is those who do the Essence of Statistics workshop, soon as you do it and you go through and you teach it, I felt like it's kind of stressful, it's difficult for people to do, that I would give people a guaranteed 100, right? However, based off some of the comments I got from the last class, and I watched it as well, unfortunately, we're going to change this quite a little bit. I do want students to participate. It is going to be an opportunity for you to improve your grade. But again, listen to what I just said. It is an opportunity, right? An opportunity is very different from you're going to definitely get 100%. Now, some of the things I'm going to look at, I'll probably make a rubric for this. But again, we need to make sure that you're serving as kind of the teacher of this assignment. There has to be some type of appreciation for the learner in the room, understanding, sharing of content, and then also the context of it. Just to let people know who have not participated in that process yet. But what we do is this: I meet with people outside of class, usually at 7 p.m. if that's working for all of us. I don't want people, if you are in this room being like, Dr. Barnes, 7 p.m. is not going to work for me. Please communicate with me because I want you to get your chance. If there's another time, I am extremely free as a result of not having to travel back and forth. So 7 o'clock for me is just a time where I'm figuring you guys are on campus. I don't know too many parties at 7 p.m. and I'm picking times that are, I think would be available for you. But if they don't work for you, and that's the only reason why you haven't volunteered, then again, you got a direct message you can say right now. I can sit back and make you a part of the next group. You'll pick that date and time, and we'll look for somebody else to join you at that time. Or I think since we're getting towards the end, we might even be able to have it so that we have one person leading the discussion, depending on how comfortable you are. But yes, I'm going to let you guys know we need to find out who's willing to do it for 11.1. 11.1 will be the Essence of Statistics assignment, which will be on D2L. It's not created just yet, but it will be up there. And your task will be to go over the problems that are very consistent with the homework. Now, it's not always all the problems, but it's a subset. So if there's anybody in this group right now that is interested in doing the 11.1 homework, that would be next Monday at 10:30, please put your information in the chat. And especially if you have a preference of 7 p.m. doesn't usually work for you, if there's a preferred time that you'd like to meet with me, it could be during my office hours or whatever, please put that requested time in there. I'm willing to meet you at your time to do that. Now, I got kind of sidetracked, but I want to make sure I understand what let everybody know what that process is. To get you guys prepared for that, we go over the Essence of Statistics homework problems. I have the homework problem solved already. Got a little scan that I usually share with that person just so they can see it. We go over the problems in Zoom. We're actually recording that session. Now, that session is actually given to that person who's designated as a student teacher. Now, this is what I just said before, like we're getting that little slippery slope. Evaluate you on this assignment as opposed to giving you 100%. One of the things that you guys need to realize that when I have a YouTube video, it's my account, I can see whether people viewed it or not. Now, this is when we're going over the problems. We're supposedly doing it together. We're asking you to ask any questions. I'm telling you kind of things that you need to share with the class. Maybe you're taking notes in real time, or maybe you'll take notes after. That video is a resource that you can use to make sure. All right, I'm getting a message that my internet is unstable. You guys able to hear me?
Yes, you're just like breaking up, kind of.
Okay, let me see what I can do to strengthen that. Okay. All right. That may have worked with the automatic update because there's a lot of servers around here. So maybe you can sit back and find the best link to get us there. Guys, do me a favor though. If I am starting to break up, if you can either like raise your hand or the thumbs up, I'll understand any type of reaction that you guys are putting in the chat would mean to me that, you know, the connection is bad. I don't want to be saying something and falling on deaf ears and you guys don't get it. So if I do have another breakup or disconnect and it's not working right, just raise your hand. It will allow me to go back to make sure that you guys hear it. Again, this is not about me opening my mouth for 50 minutes. This is about making sure that you guys learn from me opening my mouth for 50 minutes. I don't want that second part to be lost or the first part to be lost. All right, so again, that video is there to help you understand, help you review. It's kind of a preparation. What we do on Mondays with you guys being in charge, it's not something that's easy. And I want to make sure that you guys are really going over it. And if I'm doing these recordings and I'm saying that like you probably didn't do a good job or you're not really taking it seriously or not really using the screen to sit back and highlight issues, and also the video wasn't watched, that's kind of a lackluster presentation. And I think that's something that I said before. I wish I could just trust everybody to do everything they want. I want to give everyone 100 for doing it, but I might have to create some kind of rubric in which, you know, the best score might be maybe an 80% if you do something lackluster. I still want this to benefit you. But if you're doing something lackluster, it might be a 70, an 80, or maybe a 90%. But if you really want that score to be 100%, which can really impact your grade, you got to be engaged with it. The other thing is this, I understand we might be in a situation, but if this is your day to present, you need to make sure that you have the appropriate materials. You know, responding with, I'm on my phone, I can't do this, that, and the third, or my camera is not working. I can't use that excuse if I'm in charge of the presentation doing a class like this. And if it's your day to do this on a Monday, then yeah, that excuse can't be accused as well. So again, I'm expecting a little bit of taking this serious, especially for the reward that it's giving each of you. All right, I'm actually in a little bit of trouble. The reason why I say that is because I think I've asked several times about people who want to do 11.1, and I have not had any takers. Nothing has popped up in chat for me. Let me see, something is blinking. Yeah, but that's not this. Okay, all right. So that means that nobody is interested. All right, so I will find something to do. I don't want to call on anybody. If somebody doesn't want to improve their grade, okay, never mind. Okay, yes, all right. So I do have one taker for 11.1. That individual will be here next Monday. Again, the only thing I ask is this. We'll schedule it during the time. I'll sit back. You can either put it in the chat right now. All right. So I'm going to put the two of those people together. I got two people, two candidates. Perfect. I'm going to put those two people together right after class, right? So that that's perfect. I'm going to put those two people together and I'll put me on the chat as well. We can go back and forth and find out what time works for you. Like I mentioned before, I am 100% free. So the two takers for 11.1, we have them. I'll start an email afterwards. We'll communicate and we can find out what works for that. And again, don't worry. I see some people jumping in a little bit now, a little hesitation. I apologize. There will be times. We'll have 11.2, we'll have 12.1, and we'll have 12.2. So I don't want you to feel like this is the last chance, right? We'll just have other opportunities. But so the third person reaching out, you know, maybe I will put you in this group. We'll figure it out. We'll either have you for 11.2, which will be the week after, or we'll have you for this week. We'll sit back and see if we can find a time between those. All right, so let's go over this. Now, today is actually kind of a weird day, just because, yeah, I think I'm getting extremely comfortable with what we're doing in class. And I want to make sure that I can put myself in the shoes of you and what you need to be extremely comfortable in the class. All right, so what I'm going to do is, oh, I didn't know you could do that. Check it out. All right, let's look at the chat or looking at the screen. What we're doing right now is section 11.1, talking about goodness of fit, right? Now, goodness of fit, to me, actually seems a little bit confusing because I think when you talk about the correlation on the scatter plot, when we used to do before, and I'll do a little quick drawing right here. When we used to talk about drawing the scatter plots, we say a scatter plot looks like this, and then we have the dots, which are dots all over the place. right? That's just like our data. And then you would try to find the line, right? To me, goodness of fit was what I remember being taught in undergrad about what that line is called. Like that's the goodness of fit line. Like now you guys know it's something different, but it's a different way of almost doing the same thing. That line that we had when we were talking about regression, right? It was trying to find a line that best describes the information, right? We're doing something a little bit different now in this goodness of fit. And I want to bring your attention to how this is different, right, from everything else that we've done, right? When we've done stuff before in this class, we have had numerical data and pretty much numerical data only, right? Essentially, I'm going to use this kind of like it being a pun, but what we're able to do with this unit is we're able to sit back and compare apples to oranges, right? And that's a little phrase, be like, no, you can't do that. You're comparing apples to oranges. That doesn't make any sense. That's the logic that I hear from a lot of people, just being like, yeah, it is. And this means that. And I'm like, nah, that doesn't make any sense, right? But here we actually can compare apples to oranges. And the difference of that is that we're doing something that's referred to as the focus in this chapter is on frequencies, right? So we call this a one-way frequency. How come? I don't know what's going on here. Hold on. Draw, here we go. It's called a one-way frequency table. So these values that we're looking at right here, these values right here is saying, all right, we went to, I don't know, we went to an orchard and we told these kids just to take off, right? And yeah, we told these kids to take off and come back in 3 minutes. When they came back, we were just like, all right, we pick up their basket, right? And out of the 5 kids that were with us, right, we just said, all right, how many apples did you collect? We said, we found it, they got 13 apples, right? All these kids came back with 13 apples, right? How many oranges did they come back with? They picked up as many fruit they could off the ground. They came back with 12 oranges. What's some other fruits? What are some other fruits? I'm actually drawing a little blank right here. If we take some kids to go to an orchard and they go and pick up stuff, what's some other fruits they could pick up off the ground?
Mangoes.
Oh, mangoes. I don't know what farm you're going to, but you're right. Theoretically, that could happen. Pick up some mangoes. You like mangoes? That's actually, I love me a mango slushy. Oh my goodness.
I think mangoes, the fruit themselves is nasty though.
Yeah, but the way they blend them in fruits and slushy, they're good. All right, what else?
Watermelon.
Watermelon. Okay, yeah, definitely the water. Actually, I'm gonna put watermelon right here just because I'm thinking about these little poor little kids running off to the orchard and picking up stuff. They ain't picking big ASS watermelon. So I think we might only have 2 kids coming back. Dr. Barnes, can you help me? We're gonna put watermelons at the end. What other fruits?
Well, since
Oh, I'm sorry. That was duplication. Who said that?
Strawberry.
Ah, strawberries. So I'll just put straw. And then we need one more fruit.
Coconut.
it's not
I'm sorry, you guys are talking over each other. Hey, I love the participation, but again, that's how Zoom works. I didn't hear either one of you since you guys are talking at the same time.
I was going to say corn, but then I remembered it's not a fruit.
Okay, and you know what? I was going to say grapes, right? But let me tell you, who goes and picks up grapes off the ground, right? So I'm going to use grapes. I'll take the little pressure off of y'all, use grapes. But this kid coming back, I don't care if you wash a grape off. I'm not eating it off the ground, right? So literally, this is categorical data. And that's one of the things that's missing when it comes down to this. Ooh, now hands being raised, I'm a little scared. I'm not sure if that's somebody saying they want to contribute or if that means my data signal is not working right.
No, I have a question.
Okay, go right
I just
ahead.
didn't want to interrupt you. So for the top where it says outcome and you're putting all these different fruits, would it be like, and in another sense, like those are just different individuals, like different people, or is the fruit like the which are circling under the 13 the observed frequency?
Yes, great question. I did start off the story by saying like 4 or 5 kids are let off at an orchard, right? No, this data right here is ignoring the diversity of the 4 or 5 kids, right? We just had kids come back. They got all the baskets and we put all their fruit on a table. And we said, all right, guys, you're like, I could not be a grade school teacher. All right, kids, how many fruits you did? And then we sat back and we counted out. And amongst all these five kids is irrelevant, right? But out of these baskets, we pulled out 13 apples, right? Out of all
So
the kids, they don't.
one more time. I'm sorry. So the 1, 2, 3, 4, 5, 6, those represent the kids.
No, the 1, 2, 3, 4, 5, 6, one represents, that's a great question, right? The one represents apples. One is apples. Two.
Okay, so
orange.
so then one represents apples and they pick 13 apples.
Yes, those kids.
Okay, I got it.
They went out, they had fun, and they came back with 13 apples. They came back with 9 strawberries. And the reason why I'm focusing on putting names on here is because this is one of the first ways in statistics that we are now able to use not quantitative data. Quantitative data is like 1s, 2s, and 3s. We calculate the mean, the standard deviations, and things like that. Now we're able to use categorical data or nominal data. And that's what I was saying before. Now we can finally compare apples to oranges because there are things that aren't normal. It doesn't make any sense to sit back and do a t-test on how many apples versus how many oranges are here, right? Now we can sit back and compare categorical variables that represent different things. So this example doesn't really have it. This example is saying 1, 2, 3, 4, 5, 6. But I'm saying that, look, when it comes down to the goodness of fit, right? The one-way frequency table, we're now able to use categories that don't have any relevance to each other. And we call it the one-way frequency table or the goodness of fit. And we use a hypothesis test to talk about the observed frequencies. That's what these kids brought back to us, right? How many did they actually bring back to us? To find out what they do with the claim distribution. I don't like the way they said that, claim distribution, right? I'm going to highlight this because that's what they write on here. But what they really are saying is, what's the expected? What's the expected distribution? And I'm going to sit back and tell you that I want y'all to think about this. Make a little hypothesis, right? If we had kids, we took 5 kids up to I'm going to say Linvilla Orchards, right? It's an orchard near me, right? We take 5 kids out there and we say, guys, you got 60 seconds. Any amount of fruit you put in your basket is yours. 60 seconds. I got a bullhorn and I blow the horn. I'm like, right? They got 60 seconds. After 60 seconds, they have to stop, come back, and we're going to count what they've collected, right? Now, if we got apples out there, oranges out there, mangoes, strawberries, grapes, and watermelon, right? Based off these kids just going out there and getting what they want, how would we expect the frequencies to exist when they come back? When we dump the fruit out on the table, right? I just want you to talk about what you would expect. How would you expect that fruit to be distributed? Would there be like probably an equal number of apples, oranges, mangoes, strawberries, grapes, and watermelons?
No.
You don't think there'd be? Well, why do you think there wouldn't be?
I mean, I guess just looking at like how many they gathered, I mean, it's not.
Okay, and you know what? Now, again, I love this. This actually goes down to like a little bit of theory that we talk about. You, right, are looking at what actually happened, right? I'm gonna block that off, right? I'm blocking that off right now. I'm not asking about what happened. I'm saying get back into that story I just said, right? We got 5 kids. We took them up to Linvilla Orchards. We said, look, here's a basket. You got 60 seconds to grab what you want. Watermelon, mangoes, I'm going to forget it. Don't worry about it, right? When they come back in 60 seconds, I'm asking, do you think that they would kind of all be evenly distributed or they would be biased? And I think when I heard you respond, you were looking at the data being like, oh, you can see they're not even. I'm not talking about what happened. I'm using what do you expect? Do you expect that when they come back, the fruits would be kind of evenly distributed? or would there be some type of preference towards something or not?
When you say distributed, do you mean like how many they gathered?
Exactly.
Okay.
Yep. Now, again, you guys can say whatever, right? But again, I just want to ask, like when the kids go out there and do this, do you think it'd be kind of like even? Do you think it's some fruits might be more likely picked than others? What do you guys think?
I
Yeah,
think it
it's
would.
not going to be even.
They're not going to be even, okay? Right? Now, that's what we sit back and say and talk about the claimed distribution. That's what this is talking about, right? Sometimes we might think that they're not going to be even. Sometimes we might think that they're going to be even, right? But that's our claimed distribution. And the goodness of fit that we're talking about right now allows us to pick any distribution that we want, right? And we can sit back and find out whether what we actually get, right? Because that's what I'm asking y'all right now. I'm like, look, when they run out, right? What do you think it's going to look like, right? Y'all are saying, I don't think it's going to be even, right? But then when they come back, that's the observed frequency, right? So I'm going to put your money where your mouth is, right? These 5 kids had 60 seconds. They brought it back and we going to see. I said earlier, I don't think too many of these kids going to bring back a watermelon, right? Especially not in 60 seconds, right? But I got to put my money where my mouth is. Real talk. If I sit back there and put these kids out into a Linvilla orchard and give them 60 seconds, right? And it was like 60 seconds, I could get like 2 or 3 apples in 60 seconds, right? Or I could bring back to my mom and dad a big ass watermelon, right? So we don't even know, right? Even though you have a clean distribution, which is what you think, right? You don't know how it's going to work. So how it's going to work is the observed frequency, right? What we think is the claim. And that's what this table allows us to do in this one-way frequency table. One way. And it's called one way. I'm not going to get into that right now because I want to make sure. But essentially, it's called one way. Actually, no, I will, because it either has one row or it has one column. That's why it's called a one-way frequency table. And one row or column just means how you organize the data. It could be either way. But that's literally the logic of what we're trying to do right now with the goodness of fit. We need to sit back there and see if we're trying to make an assumption about a claim distribution, and we're going to sit back and see whether or not what happens in 60 seconds with these kids matches what we think. Put our money where our mouth is. We're going back to hypothesis testing. All right, let me clear this off. All right, okay, observed frequency. Let's see what they actually get. Now, to make sure you understand this, I want to make sure we get into some notations, right? Some of the notation that are going to be relevant to make sure that we can follow along with this discussion is O, right? Who can read for me? What does O mean?
The observed frequency of an outcome found from the sample data.
All right, so that's what happened. We took these 5 kids up, gave them 60 seconds, right? What did they actually bring back? The observed frequency. And that's from the sample data or this kind of experiment that we've done, right? So that's the observed frequency. That's what the O stands for. Perfect. Anybody lost on that? Want to go back a little bit more? I'm using this analogy of kids at Linvilla. Let's sit back and get that point across. Okay. Now, what is E? Who can read E for me?
It represents the expected frequency of an outcome.
There's a little bit more.
Found by assuming that the distribution is as claimed.
Exactly. So Dr. Barnes ran his mouth and sat back and said, these kids ain't going to come back with no watermelons, right? So I expect it, right? And that's my claim. So I'm thinking it's going to be less watermelons. But let me tell you, I also came back and said that maybe they're going to come back with only watermelons. The E is the expected frequency. When we do the test, I got to make up my mind. Dr. Barnes has to sit back and say, look, they either going to come back with a little bit of watermelons or a whole lot. I can't be teeter-tottering between both. I need to sit back and say what I expect. So E is the expected frequency. You've got to make a decision. Doesn't matter. And that's the beauty of this one-way table. It doesn't matter what I predict, right? I'm free to predict whatever I want, but I do need to make sure it's concrete. Okay, now I'm going to read the next one, which is K. K represents the number of different categories or cells, right? Now, these are numbered, right? We made them apples, oranges, mangoes, strawberries, watermelons, and ooh, I forgot one, right? But again, we made those categories. Okay, you know, I feel bad. I think somebody tried to say what it was and I didn't hear it.
Did you say grapes? I think it was grapes.
Yes, grapes. That's right. I said grapes. Ugh. Can't imagine picking up grapes off the ground, right? So K is a number of different categories. Right here, there are 6 categories, right? Now, it doesn't matter how many categories I have. The only thing is, you have to remember that I'm still talking about one factor or one row, because that one row is different types of fruit. I could add more types of fruit if I wanted to. I could add a pomegranate. I could add a
Kiwi.
what she just said, a kiwi, or I could add more. As long as it's going to fit in that one row and it's a type of fruit, I can still add more cells. But we do need to know how many cells. So we got to count. We got 6 types of fruit, 6 different cells, right? Now, the next is this, right? We need to go into N. Now, N is unique, and I'm going to ask someone to do this. And honestly, you guys might, this might be challenging with the example I gave. Yeah, this actually will be challenging with the example I gave, because the example that I gave, finding out N is kind of based on how much, what happens in that 60 seconds. That's all I'll say. So what is N? Someone can read that for me. And then I'm going to ask you guys to tell me, what do you guys think N is?
The total number of trials.
All right, the total number of trials, right? Now, in my example of letting these kids out, who let the dogs out, right? In this example of who let the kids out, right? What would be our N? And be careful. I think it's happened before. I don't want you guys to look down here at this table, because remember, my example of apples and the kids for 60 seconds, that's not tied to this example. This is another example, right? But I'm saying this, if we let kids go to Lynn Villa with a basket for 60 seconds and they can bring back whatever they want and it's there, what do we think N would be?
N would be 1 because you only did it 1 time. If you told them to go 2 times, then N would be 2. So it's how many times you let them go out and do that 60 seconds of picking.
You know what? And let me tell you, I almost want to apologize to you, Jasmine, because again, I led this up, right? I said it was kind of challenging, right? Now, here's the issue. If the only way it would be 1 is if I went up there, right, and I said to a kid, you got 60 seconds to pick 1 fruit, and you bring that 1 fruit back. It's not 5 kids, it's just 1 freaking kid, right? You go and get 1 fruit and go. That's what kids do when they go for when I used to take my kids for get their like their pumpkin for like Halloween. You go back, you can get 1 pumpkin. I don't care which one it is, you get 1 pumpkin, right? So that 1 kid would go out, bring back that 1 pumpkin, it'd be 1 trial. But listen to what I was saying in this example. And I did this on purpose to make it so that we have to think critically about what we're saying, right? These kids had 60 seconds. They had a basket, right? They can bring back as much fruit as they want in that basket. And then I also said that once they bring that basket back, I'm gonna dump the baskets out and then I'm gonna count, right? So I'm not gonna put the pressure on anyone else. But
So N is 6, right?
All right, no, and wouldn't be 6 either. And wouldn't be.
Wouldn't it be the total number of fruit they brought back in total?
Exactly. It's the total number of fruit that they brought back. Now, this right here, this example, I kind of want to apologize, right? Just because it takes a little bit more understanding to get there. But essentially, if you count N on this graph now this is not about the kids and the fruit, right, on this table, but the value of N in this example would be the result of an individual adding up these values. N would be 13 because they brought back 13 apples, 6 because they brought back 6 oranges, 12 because they brought back 12 mangoes, 9 because they brought back 9 strawberries. They brought back 3 grapes, which makes sense because they're like, that's disgusting. And then they brought back 2 watermelons. That's what N is going to equal, right? So it's not tied to the number of kids. It's not tied to they went up there 1 time. It's how much fruit did they bring back? And I'll tell you, what I just gave you right now for this example, this is probably one of the more complex vignettes that anybody will give you. So I apologize for that. But if you're here with me and engaging, if you can do this, my argument is you can do all the other stuff in the textbook, because the textbook's not going to be so challenging. It's not going to be so straightforward. And yeah, I think I kind of apologize for that. So sorry, Jasmine, I think I set you up with that. That definitely was a hard problem. But again, a little bit of thinking about it does it. And again, I tell people, I think people learn the most when you make mistakes. It's not about displaying what you already know. It's better about, oh, dang, I messed up. I might feel a little bit embarrassed, but now I know. Okay, now what is P?
Is P based on the expected frequency?
Okay, now you know what? I might have been looking clear. Say it again. Can you read what's up here again for P?
Represents the probability that a sample value falls within a particular category.
All right, so it's the probability, right? So it's a different way of looking at it, right? Now, if we find out what N equals, what we could say is this: I got a hypothesis, right? And I'm going to sit back and I'm going to use people. Yeah, we got a little bit of time to do this. Okay, Jasmine, because I set you up before, right? Now, when they run out there and they getting apples, oranges, mangoes, strawberries, grapes, and watermelon, right? What percent of the fruit after 60 seconds that's on my table from all these kids, what percent of them do you think are going to be apples?
Can you give me a second to do the math?
No. Again, I'm just talking off the top of your head. Not about solving this. What do you think? We got 4 kids, run out there, 60 seconds. What percent of what they bring back do you think is going to be apples?
Probably like 15, 20.
All right, so we're going to put a probability of 0.15. Okay, now I said oranges. Do I like oranges? I'm gonna say I like orange. That's probably my second best fruit. So I'm gonna do oranges at 0.12%, right? Okay, now who did mangoes, right? Who said mangoes? You can give me a percent of that. What percent?
I said mangoes.
All right.
We already got 15 and 12. It has to equal to 100. So I'll say 30%.
30%. Now you know what? What I'm trying to show, this is how I sit back and I love this, guys. You guys don't realize how much you already know, right? I sat back a second ago, I was like, I got time to go into something, right? Jasmine's last comment already almost felt like she stole the thunder from exactly what I am about to try to show you, to understand what degrees of freedom is. She sat back, and before she sat back and said 30%, she looked at what was already there. And I'm gonna show you how. I'm going to ask for more volunteers, but it's going to get to a point where I can't ask any more questions of you. I can't ask any more questions. All right, so who said strawberries? I feel like that was, is that wisdom?
Yeah.
All right, what percent do you think these kids gonna bring back these strawberries now? These kids, I don't like seeds when I was a kid. I can eat it now. What percent? And I'm trying to bias you. Say whatever you want.
Oh, maybe like 13%.
You said 13?
Yeah.
Okay, 13%. All right, now I need an individual to do me a favor and to add these values up in addition to the next one. And I said grapes, but you know what though? I'm biasing y'all a little bit. I need somebody else to give me what percent do you think kids are gonna come back with grapes? Another volunteer.
It's 70.
70%? Oh, now you know what? Now we can't do that. Let me tell you why we can't do that, Deja, right? What Jasmine said before is that these percentages have to add up to 1, right? Now, you guys might remember this from a long time ago, but we used to have like probability tables that we put out, and we talk about the certain values. And one of the things they always said is that if you're doing a true probability, the values have to equal up to 1.0 or be close like 0.999. Oh my, I'm sorry, guys. My hand is not working today, right? Now, if we do 0.70%, right? with grapes at 0.70 and mangoes alone, that would be a perfect score of 1. So then these would make us go a little bit over. So you are a little bit constrained, right? We have to have a value that allows us to still be below the 1.0. You can take it again, or somebody else can give me a number about what they think the probability of kids bringing back grapes.
You could put 10. I think she was saying the number of them added up was 70. So we have 30.
Oh, that's what, you know what? I'm so sorry if that's what she said. I'm not sure if I'm not hearing because of the internet. Wow, that was a 50. Okay, so what you're saying though is a 0.10?
Yeah.
All right, so we got 0.10, right? Now, this is what we can't do, and this is what degrees of freedom is, guys. Right? This is what degrees of freedom is. When people say degrees of freedom is n-1, essentially what the meaning behind degrees of freedom is this. I asked all y'all can just come up with any number out of your ass about the percentage of fruit that these kids bring back. But once we get to n-1, because there's 6, right? Once we get to n-1, which in this example equals 5, you no longer can come up with any number. And as a matter of fact, without even doing the math, I can sit back and assure you guys, we know for a fact, who else can do this? We know for a fact that the probability of kids coming back with a watermelon is what? What's 20. That? 20. See, I feel bad. I think I'm so far away from Cheney. There's so much more of a lag right now. I think that's what's happening and causing this. I'm sorry. I need to stay home and not do nothing.
I have a quick question, Dr. Barnes.
Yep.
For the degrees of freedom, so the outcome is what we would subtract 1 from, right?
The outcome is what you would subtract 1 from.
Like, since outcome goes up to 6?
Yes.
Because it was 6 trials, right?
Yeah, or 6, it was categories.
6 categories, okay.
6 categories, right? So 6 categories right here. And then degrees of freedom is saying that. So, you know, you can, when you want to sit back and make these expected frequencies, you can come up with any of these numbers you want. But that last one right here, that one right there, that blue one, since it's last, it doesn't have to be watermelon, right? But the last one you pick, it's defined because we have certain rules that we must follow, right? Now, with these rules, we need to make sure that probability is equal to 1.0. So that's why it's fixed. And that's what the notion of degrees of freedom is. Degrees of freedom is looking at our statistics, right? And they're saying like, okay, we need to come up with any number in the world in order to find out whether this is significant or not, right? What's the wiggle room? How much can we play with these numbers before it has to be fixed, right? And that's what degrees of freedom is. Now, I don't want y'all to go too detailed. Like, this is like what I just told you right now and showed you is probably like some graduate level stuff, right? In terms of understanding that. I just want you to get some understanding. You guys might be doing DF for all these things. It's always n-1. I don't understand why the hell is n-1. This is, I think, a neat way to kind of show you why it's n-1 or whatever it is. It could be k-1 or whatever. Just because after making this, we made up all these numbers right here. We made them up. We had so much fun making them up, right? But that last one, I'm sorry, we couldn't have fun no more, right? And that's because we only have 5 degrees of freedom out of making up 6 numbers, right? And that's just yeah, that's, I think it was a neat way to slide that in, which is so just take that as a I don't know, like a little take home. I kind of get it, but don't worry about it. Don't ask me to go into detail exactly why, because yeah, then I would lose you. I'm not trying to do that. All right. So yeah, that's kind of what degrees of freedom means, especially in relevance to this example right now. Because again, that last person, I picked him, but yeah, it had to be 0.20. It had to. And my bad, Deja, for hearing you wrong. I thought you went on to saying that you thought 70% of the kids were going to pick up grapes. And honestly, I was just like, ew. You got these kids picking up grapes off the floor. They probably stepped on. But yeah, I'm glad I understood you correctly. Yeah, so let's go there. So that's the notation that we're going to need. And this notation is going to be important, right? Let me see if I can clear this. Now, how do you write null hypotheses for the goodness of fit? They kind of look like this. A null hypothesis, as you guys can always say, right, might sit back and say that it agrees with the claim distribution. Now, it's a little bit different from what we did before. Remember, obviously, you say like, equality always means certain things. What we do here with this, you're going to use equality for the null, but these values can be whatever they want. And I'm actually going to make sure that I do that. Like we actually started doing this. We're saying that the probability for one, which we're saying were apples, was like 0.15. The probability for oranges we put down was, oh, I forgot that value.
1.2.
Okay, 1.2. And then the probability for mangoes was 1.3?
30.
30. Oh, that's right. Okay. Right. And then 4 was our strawberries, right? And then the last one, I'm going to put right here, this one has to be fixed. Notice I want you to realize this is kind of going on and on. It's continuing. It's not having 5 and it's not having the other aspect. But for 4, which was, that was our strawberries, right? What was the probability of 4?
15.
15, right? And honestly, I think just for make sure we have clarity, I'll add P of 5 here. P of 5. And that should be equal to 13, I think. Right, this is what the null hypothesis will look like if we're doing a null hypothesis for this. And it's essentially in P of K, again, it's saying how many categories, right? In this example that we're doing, we have 6 categories. So P of K is going to be that 6 that we just got rid of. So this is how we would write our null hypothesis. We believe that the probability of apples is 15, oranges is 12, mangoes is 30, strawberries is 15, grapes is 13, and watermelons is
Them numbers is wrong because that's going to be 105.
That's
So,
105. Where'd I mess up then? Hold on, let me see.
15 is not a number 15. That was 13, and then it was 10, 20.
All right, 15, 12, 30, 13, and 10. Okay, you're right. I see it. 20. All right. This is so annoying with this. So this is 13, and this is 10, right? Here we go. We got the A-OK from you now, Deja? Thank you. And again, I love that. That means we're on it. And that's exactly what I'm doing. Honestly, I had a couple questions in the chat like, man, are we on punishment? Like we are an experimental, got to have our camera on. For these reasons, that's why you guys are not. I really feel like you guys are engaged in what you're calling me out. You're attending. It doesn't make sense. You're there. We need to make sure we keep that culture. And I'll let you guys do what you guys do. All right. So this is what the null hypothesis would look like, right? Now, it's not on here, but I'm going to do it. What the alternative hypothesis would look like is pretty much the same thing we're writing right here. I'm going to bring this down a little bit. We would essentially, and I'm going to cheat because I think it would save some time for me. The alternative hypothesis would say they're not equal to it. They're not equal to it. They're not equal to it. It's not equal to that. It's not equal to that. And it's not equal to that. All right, so that's what the alternative hypothesis would look like. That is how we will write our null hypothesis and our alternative hypotheses. Right? It would be equal to whatever probabilities we're saying, right, for each category. And then the alternative hypothesis would be like, oh, it's not equal to that. It's not equal to that. It's not equal to that, all the way up until we have everything accounted for. All right, is anybody lost on this? I don't think I want to go anywhere further today on this concept, but I want to make sure we're going to do this because this is going to be part of the homework, right? And I want to make sure that you guys have this. We got 2 minutes to sit back and expand on. I don't get this. Let's go over it so we can start running tomorrow. Tomorrow we're going to take off. Not tomorrow, Friday. It's Friday we're going to take off. The other thing I'm going to suggest is this. Again, I think tomorrow, what I want to, I keep saying tomorrow, Friday, we're going to do a handout, and I would like for this handout to be completed and submitted in a Dropbox when we go home, when we're done with the class. So if you guys can make sure that you're either on a computer or as opposed to a flash drive, I'll look and see if I can work on my iPad, but I might give you guys a warning just to make sure that you don't have to do anything after class. If you do it during class, you upload it, you save it, you're done, you keep it moving, right? But if you're not behind a computer and we do this activity, then we'll talk about it in class and you got some additional work to do. But I kind of want to go over the assignment and have an activity that we're doing. You know what? I'm going to be nice to y'all. I won't do that. What I will say is this. I'm going to send y'all an email. I'm going to email it to you. So there's going to be a handout that I want you guys to do. I remember laughing at a colleague. He was trying to have people see a handout. I'm going to email this handout to you. It's already on D2L. But what I just need is for you guys to print that out. So if you can print that out and have it in front of you on Friday, that'll make it so that we can kind of be engaged and maybe we can take a picture and put it in Dropbox when class is over. So I will send that with the class right after I send this email about connecting the people who are going to work on 11.1 together. I'll send this attachment to all of you. And if you guys can print that before class, then we can continue what we're doing. It doesn't have to be anything fancy, it doesn't have to be behind a computer, as long as you got a print out of that. So that's about 48 hours, I guess, for you guys to go print out one sheet of paper so that we can get some hands-on work when we get here on Friday. All right, everybody, that is all I got to say for today's class. Thank you very much.